Okay, this is part 2 of the review of sine and cosine graphs to help you get a better handle on how to do the sine cosine. I'm looking at problem number 9, and our instructions for this problem were to give the amplitude and period of each function graph below, then write an equation of each graph. Okay, so we're looking at 9. First, we want to look at what type of graph it is. You have to decide if it's a sine or a cosine graph. The way you know, again, is to look at 0. If the curve at 0 degrees crosses at 0, we know that this is a sine curve. So we know that we're going to be using y equals a sine bx. Now we just have to find our a and our b, and we have our equation of this graph. The A is the amplitude. How high does it stretch up is the question you're asking, and the amplitude is 2. Excuse me, so we know that A equals 2. B, we know that the period is how long it takes for it to repeat itself, is equal to 2 pi over B, and we're trying to solve for B. So first we have to look at our graph and see how long of a time period does it go before it repeats itself. So if you look at 0, it starts here, it goes up, goes back down, and starts up again at 4 pi. At 4 pi, it looks like it starts repeating. So our period is equal to 4 pi. So we substitute that in this equation, and we get 4 pi equals 2 pi over b. And then we cross multiply, and we get b times 4 pi equals 2 pi, and divide by 4 pi, and we get b equals 2 pi over 4 pi, which is 1/2. So b is equal to 1/2. We now substitute that in we substitute our b in, and we substitute our a into the equation, and we get y equals 2 times the sine of 1/2 x. Notice the a tells us it goes up to 2, and then its low point is at -2, which is a distance of 2, and then the b is 1/2. So the period is actually stretched out longer. Okay, let's look at 10, because 10 gives us a good illustration of the cosine curve. How do you know? Again, look at 0, and you see that it does not cross at 0. It crosses down here at -5. Therefore, we know that this is a cosine graph, because if it was a sine, it would be at 0. So let's find a and b. So a is the high point, or the distance, which is 5. And the low point is also a distance of 5. And then the period is equal to 2 pi over b. Let's look at when this is repeating itself. It looks like our period starts here, then it goes up, then it comes all the way back down and starts again. So it looks like the period equals 2 pi. So you have to look at the graph and interpret it before you can fill in these values. So we get 2 pi is equal to 2 pi over b. Now cross multiply. This times this. We get 2 pi b equals 2 pi. Solve for b. Divide by 2 pi on both sides. And we get b equals 1. So we're going to substitute our a equals 5 and our b equals 1 into our equation to get y equals 5 times the cosine of x, and that is the equation of this line, or this graph curve. Okay, let's try to move on here and do number 11. Number 11 says it's just not letting us go. Okay, graph the following. Sketch the graph of the line of the function over the interval -2 less than or equal to x, less than or equal to 2 pi. We have y equals 4 sine of x. So label your a and b first. So we know that a is equal to 4 because a is in front of sine. And then b is equal to whatever's in front of the x, which is a 1. So b equals 1. Now when you graph this, remember, keep this in mind. It's a sine curve. Because it's a sine curve, okay, the normal sine curve starts at 0 and then hits 0 again at pi and hits 0 again at 2 pi. And then normally it goes up to 1 at pi over 2, and it goes down to -1 for 3 pi over 2. So this is your normal sine curve. That's how it's always graphed. Okay, now let's change this color here and see if we can do this graph. The only difference is going to be, okay, we're still going to have the same points at 0 for this sine curve. The only difference is going to be where on the original sine graph we went to 1 and -1, we're going to go to 4 and -4. So here we will go 1, 2, 3, 4, and here we will go 1, 2, 3, 4. So our graph now is going to look like this. And that's all you do. You just go from the original graph that you know of, and you stretch it if there's an amplitude. Okay, let's try 12. So 12 we have, let me see here, let me erase this information here if I can. Okay, and we'll go back to our pen and let's do a different color here. Yay. Y equals 2 cosine x. A is equal to 2. B is equal to 1. So the cosine graph, what does the cosine graph look like? The normal cosine graph, y equals, okay, let's try this again, y equals cosine x. Normal cosine graph, we learned this right at the beginning, and then you have to kind of memorize it. At 0, it starts at 1. Okay, it then hits 0 at pi over 2, then it goes down to -1, hits 0 again, and then goes back up to 1. So the cosine curve looks a little different than the sine curve. It starts at 1. Sorry for that there. That's not a very good graph. There we go. So let's now look at what we have to do differently. If our A is 2, the only thing we have to do with that is this. Instead of being at 1, we go up to 2. Instead of going down to -1, we go down to -2. Instead of going up 1, we go up to 2. The zeros stay the same. They always do. So now our graph is going to look like this. See that? See how we stretch the graph up to 2 instead of 1? So you always go from your basic graphs, and then you determine what you have to do to change things. Now these two were pretty easy, so we're not going to have too much trouble with them. But let's try to move on here and see if we can find something a little different. Let's try this next one, if it lets us. And we have y equals, it's just determining to be just a bit of a pain. Okay, y equals 2 sine 2x. Now this one's going to be a little bit different. So we have A is equal to 2 and B is equal to 2. So our period, where it repeats itself, is going to be equal to, oh, that's a mess. Period will be 2 pi over b, which is 2 pi over b is 2, so it's going to be pi. So this time the period is pi. That means the graph repeats itself at pi, not at 2 pi like we're used to seeing. So what we're going to have to do is figure out our new endpoints, because before it was 2 pi, 3 pi over 2, pi, pi over 2, and 0. But now we're saying it's only going to pi before it repeats itself. It's going to do more than one repetition within 2 pi. So you have to take the period pi, and you have to then find out each interval. What are our in-between points? You do that by taking 1/4 of pi. 1/4 times pi equals pi over 4. That will be your in-between point. This is pi over 4. To find the midpoint, you take pi over 4 times 2, which gives you pi over 2. So pi over 2 is our midpoint. We then take pi over 4 times 3, and we get 3 pi over 4, which is here. And then we have pi. So our graph isn't going to go all the way to 2 pi. It's going to repeat itself at pi. at pi. So it's the sine curve. So we know the sine curve always starts at, let's get a different color here that we can see better. I liked that orange. Well, I guess not. It's not letting us change color for some reason. Okay. So let's go back to y equals 2 sine 2x. For some reason it is not responding. Word's not responding. That's great. Okay. Hopefully I can get this to start working again. Good. Okay. We'll stick with the green, I think. Okay, so the sine graph. The sine graph always starts at 0 for its first point, and it's every other point for 0. So normally we would do 0, pi, and 2 pi, but we do every other point. So now we've scrunched our values down. So we have 0, pi over 2, because we're going every other point, and then pi for our zeros. Now what is a? A is 2, so this value will be up to 2, and this value will be down to -2. And our graph is going to look like this. And that is the graph of y equals 2 sine 2x. Notice we had two things going on here. We had an a of 2, which brought it up to 2 instead of the 1. And then we had our b, which was 2, which changed things quite a bit. The normal, if it'll let me, let me see if it can let me change colors. The normal y equals sine of x curve would have been 0 to 2 pi. 0 to 2 pi. So we would have had 0 at the same places. Okay. 0, pi, and 2 pi. And then remember the in-between values would be, 1, and the in-between value would be -1. So the normal sine curve looks like this. But in our graph, you see what's happening. We're stretching it up to 2, and we're also closing it in within, it's repeating every pi instead of every 2 pi. So hopefully that is giving you a little bit more information on these graphs, and this will work out.